Okay, in this video I'm going to go through the pure mathematics and statistics paper that my students sat in January 2023 as a mock examination. The A-level further math students sat this paper, so I will go through this one. This was the full paper, and then all the ones who don't do further maths, they had a slightly modified paper to allow for content that's not been covered at this point. So they had 3 questions that were on their paper that weren't on this paper, and I'll go through those at the end of the video. I am going to attempt to try and do this whole thing in one take, but if that fails, then you might have multiple videos, but they'll all be sequential. Okay, so without further ado, let's crack on with this paper. Like I said, this is the one that the further maths students sat, so there are 13 questions in this one, and I will give the question numbers as I go for those students who don't do further maths. So, question number 1 was question number 1 on the other paper as well. So in this question, you must show detailed reasoning, solve the following equation. So we've essentially just got 3 equations that we're going to solve. And when it says show detailed reasoning, it just means that you need to show your algebraic steps in a bit more detail than perhaps you would to just solve the equation. Okay. So this is the answer book. I'm going to write the answers in the answer book as we go. So solve this equation. So at the moment, what I'm noticing is we've got 2 fractions summing together, and I know that when to add 2 fractions together, the common denominators have to be the same. So I'm going to times the left fraction top and bottom by x plus 2. So I have this then denominator of x plus 1 times x plus 2. And then I'm going to times the right hand fraction by x plus 1, top and bottom, to give me that same denominator, x plus 1, x plus 2. And now that the 2 denominators are the same, I could just add the numerators. So that's going to be x into x plus 2 minus, and I'm going to call this x squared minus 1, because that's the difference of squares. And that's divided by that denominator, x plus 1, x plus 2. This is all equal to 0, by the way. I've not changed the equation. I've just rewritten the fractions. There are other ways to do this, but this is the way I'm going to do it. Okay, so now I'm going to times top and both sides of the equation by this thing, and as long as the numerator isn't 0 as well, when this is 0, then that's not a problem. So what I'd recommend in these types of questions is when you get to your x answers at the end, just plug them back into the original equation just to make sure that they're correct. Okay. So that implies then that this is going to be equal to 0, because if you want a fraction to be 0, you just need the numerator to be 0, provided the denominator is not 0 as well. So that's going to be an x squared plus a 2x minus an x squared minus minus 1 is equal to 0. The x squareds will cancel, so we get 2x plus 1 equals 0, and therefore x equals minus a half. Okay, that's the only solution that I seem to have from this equation. What I'm going to do is I'm going to run that number back through this original question just to make sure that is indeed correct. So if it doesn't satisfy the equation, then I've done something wrong in my working. Okay, so minus a half was the answer I got, so I'm going to plus minus a half and then equals, and then I'm just going to dump in answer divided by answer plus 1, and then minus answer minus 1 over answer plus 2, and that should equal 0, which it does. So that confirms to me that at least this answer is correct, and it does satisfy the equation. Doesn't tell me if there are any missing answers, but you know, I'm happy that this is the correct answer, and following my algebra, I'm happy that that is indeed the only correct answer. All right, part B. So this one is a little bit different, but it's still just solving an equation. And the first thing I'm noticing here is I've got fractions in there. So I'm just going to get rid of the fractions, and I'm going to do that by timesing the whole thing by x to the power 6. So the first term will then become an 8. The second term will then become 7x cubed, and the last term will become an x to the 6. And that's going to equal 0. And this is now a quadratic in x cubed. So that's going to be x cubed plus, x to the 6. So it's a quadratic, quadratic in x cubed, plus 7x cubed minus 8 equals 0. So I times it with minus 1 and just rearranged it. And then I can say x cubed is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. 49 plus 32 is 81, so that's 9. So I get minus 7 plus or minus 9 over 2. So minus 7 plus 9 is 2, so 2 over 2 is 1. And minus 7 minus 9 is minus 16. And minus 16 over 2 is minus 8. So that's my two solutions for x cubed. And then I can just cube root those to get me my solutions for x. So I get, therefore, x must be the cube root of 1, which is 1, and the cube root of minus 8, which is minus 2. And those are the only two real solutions. Okay. All right. This one here. So this is an exponential equation, because we got an unknown in the exponent. So what I'm going to do is I'm just going to take log to the base 3 of both sides so that my exponent becomes the subject. So I'm going to have x squared minus 7 is going to be equal to log to the base 3 of 1/243rd. And that's just a number you can put into the calculator. But 243, I recognise that number as a power of 3. I think it's 3 to the power 5. So therefore that's going to be minus 5 because it's 1 over. But yeah, you can just stick that in the calculator, and then that should give you the answer. In fact, I'll show you to do that anyway. So log to the general base, so base 3 of 1/243rd. There you go, minus 5. Add 7 to both sides, so we have x squared is therefore 12, and that tells us that x is going to be plus or minus 2√3. Excuse me. That's not right at all, because I've added 7 to 5, not to minus 5. That was really silly of me. Easily done, but no marks from there. Minus 5 plus 7 is obviously 2, so that'll be x squared equals 2, not 12. So that tells me x equals plus or minus √2, not 2√3. Okay. That finishes question 1. All right, question 2. So question 2 on the further maths paper was also question 2 on the regular maths paper. This is the last time that happens, by the way. Every other number is different. Okay, the points A and B have position vectors 3i plus 2j and 4i plus 2j minus 5k respectively. Find the length of AB. Okay, so the length of AB, we're just going to use Pythagoras on this. So it's going to be the square root of the difference in x squared. Now, the x coordinate is 3, and then it goes to 4. So the difference is 1, so 1 squared. Difference in y, it goes from 2 in the y direction to 2 in the y direction, so there's nothing there. And then in the z direction, it goes from 0 on the point A up to minus 5 on the point B. So that is a distance of 5. So applying Pythagoras in 3 dimensions, you still square the numbers inside, but you square root, don't cube root, common mistake, and that equals the square root of 26. You only want the positive root because it is the distance. Okay, so that's nice, simple 2 marks. Point P has position vector pi minus 3k, where p is a constant, and p lies on the circumference of a circle of which AB is a diameter. Find the 2 possible values of p. Okay, so what I'm thinking here is we've got a circle somewhere out there in 3-dimensional space, and AB is a diameter, and then we've got this other point P, and it says there's 2 points for it, so maybe there, and maybe over there somewhere, I don't know, P1 and P2. And we need to find essentially the coordinates of P, but it's just the x coordinate. Okay, so AB is a diameter, so that tells me that the centre of the circle must be the midpoint of A and B, okay, because this is a diameter, from A to B is a diameter, so therefore halfway between these 2 points is the centre. So the coordinates of the centre are going to be 3.5, 2, and minus 2.5. So I'm just finding the midpoint of these 2 points. So that's the coordinates of the centre of the circle, and we know that the distance from P to C distance from P to C, that must equal the radius, but we know the diameter is root 26, so the radius is going to be half of that, so half root 26. Okay, so that should hopefully give us now a quadratic equation in P, which we can solve. So looking at this point P over here, P in the x direction has coordinate P, so the distance from P to C is going to be P minus 3.5. Doesn't matter if that's positive or negative because you're going to square it. In the y direction, it's going to go from 0, there's no j over here, to 2, so therefore that's a distance of 2. And in the z direction, in the k direction, it's at minus 3, and we want to get to minus 2.5, so that's a difference of 0.5. Okay, and we want to square root that, and we want that to equal a half root 26. Okay, so that's now a quadratic equation in P. So we can simplify that. So inside the square root, we're going to have P squared minus 7P plus 3.5 squared. So that's 3 times 4 plus a quarter. So that's 12 and a quarter. Plus the 4 plus the quarter. And I've squared both sides, so I got rid of the square root here. So the square root of this side is going to be 26 quarters, which is 13 halves, which is 6.5. Okay. Neaten it up a little bit more, we're going to get P squared minus 7P plus 16.5 on this side, minus 6.5, so that's plus 10. Okay, so that's definitely a quadratic we can factorise. So we've got minus 5 and minus 2. And that tells us that P equals 2 or 5. Okay, check that that's answered the question, because it might have asked for the coordinates of P. And find the 2 possible values of P. Great. Okay, I don't need to take the coordinates. Those are the 2 possible values of P. Job done. Okay, question number 3. So this one was not on the regular maths paper. So if you're doing regular maths, you're going to have to skip ahead to the next question. So this, oh no, it was on the regular maths paper. Yes, this was on the regular maths paper, but it was question 4, not question 3. Apologies. Okay. Or was it on the regular maths paper? Oh, I can't remember my notation now. Yes, it was those 2 that went. Yes, this one was on the regular maths paper, but it was question number 4. Okay. So question number 3, which is this question here. Amaya and Ben integrated 1 plus x squared with respect to x using 2 different methods as follows. Amaya seems to have used some kind of substitution quickly. So she's just added 1 to the power divided by new power and then added a constant, which is fine. You can do that because the derivative of the substitution is 1, so that's not a problem. And she's got, and then she just multiplied out the brackets. Okay, fine. And then this one here, Ben, he's multiplied out the brackets to start with, and then he's integrated each term. And they are different answers, but they are still correct. Charlie said, because these answers are different, at least one of them must be wrong. Explain whether you agree with Charlie's statement. So, no, I don't agree with Charlie's statement. And that's because the 2 answers only differ by a constant. I mean, we could equate them. We could say that Ben's constant, so i.e., let's call it constant B for constant Ben, is going to be the same as Amaya's constant plus a third. And because the C is arbitrary, you can do that. You can redefine a constant like that because it's an arbitrary constant. Doesn't matter what it is, it still satisfies the original integral. So they're both correct. Okay, part B. You are given that A is a constant greater than 1. Find the integral from 1 to a of 1 over x, 1 plus x all squared with respect to x, giving your answer as a single fraction in terms of the constant a. Okay, so we actually need to carry out this integral. So it's a quick little substitution. there are other methods out there. I don't really like inspection type methods, so I'll do a substitution. So I'm going to say u equals 1 plus x. That tells us that the u by dx is 1, and we can change the limits on the integral. We've currently got limits of 1 to a, and because u is x plus 1, then that's actually going to go from 2 to a plus 1. Okay. And now the integral is going to become the integral from 2 to a plus 1 of u to the minus 2 du. Okay, so du by dx is 1, so therefore du equals dx, so that dx there just gets replaced, and that becomes u to the minus 2. Okay. You don't have to do this method, but this is just the way that I would always do these types of questions. Okay, now we can add 1 to the power, divide by new power. So it's going to be minus u to the minus 1 between 2 and a plus 1. So we're going to have minus 1 over a plus 1 minus 1 over 2. Okay. I think that's correct. Oh, it does say a single fraction. Okay, so I've got to give my answer as a single fraction. So just like in question 1, I'm just going to combine these two together. I'm also going to swap the order, so I don't have to keep writing a minus sign. So I'm going to have 2 a plus 1 divided by a plus 1 minus 2 over, oh, sorry, this should be 2a plus 1. 2 into a plus 1. So this one's gone over here, so I've times it top and bottom. Oh, that shouldn't be there. Times it top and bottom by a plus 1. And then I've times this one top and bottom by 2. And that's going over this side. Now the two denominators are the same. I'll end up with a plus 1 minus 2, which is a minus 1, divided by 2 into a plus 1. Okay. And a is bigger than 1, so that will be positive, and I don't have to worry about the bottom being 0. So, brilliant. That satisfies that. Part B. No, sorry, part B, part 2. Okay. You were given that the area enclosed by this curve. Okay, it's the same curve, so that curve is the integrand from the integral up here. The x-axis and the lines x equals 1 and x equals a, and we're told it's equal to third. Determine the value of a. Okay, so all we're going to do is take our answer from this answer up here and set it equal to a third, and then solve it, rejecting any answers that are less than 1. So it's going to be a third. Let's get rid of the fractions. I'm going to times the left-hand side by 3 and times the right-hand side by 2a plus 1. So it's going to become 3 into a minus 1 is equal to 2 into a plus 1. So 3a minus 2a is a, and 2a plus 2 plus 3 is 5. So a is 5. Okay. Part C. In this question, you must show detailed reasoning. Find the exact value of this thing, giving your answer in its simplest form. Okay, so what I'm noticing here is the top is almost the derivative of the bottom, and that is one of those special case integrals which makes the integration very quick. So I'm just going to change this integral so that the top is the differential of the bottom, but I'm only going to do it by timesing or dividing by constants. Okay, you can't bring variables in and out of the integral. Okay, so it's between 0 and pi on 12 of sine of 2x plus 2 divided by cos of 2x dx. Now, if I were to differentiate the bottom, I would get 2 cos 2x. So I need this to be 2 cos 2x, but in doing so, I've just times the whole integrand, which is the contents of the integral, by 2. So therefore, I need to times the whole integral by a half to make sure I'm keeping it the same value. So this integral now is exactly the same as the question integral. However, within the integrand, the top is a differential of the bottom, which means I can state this as being the natural log of the bottom. If the top is a differential of the bottom, the integral is a natural log of the bottom. Technically, the natural log of the mod of the bottom. Okay, so it's pi on 12. All right. So we now have this thing. And what's the exact value of this? So I'm going to plug in my limits. So we're going to have a half times the natural log of sine of pi on 6 plus 2 minus the natural log of sine of 0 plus 2. Okay, so I've just plugged in my upper limit over here and my lower limit over here, and I've just left the half sitting out the front. So that's going to be a half into sine of pi on 6 is sine of 30 degrees, which is a half, I think. Probably shouldn't do that so quickly in my head, should I? Double check. Sine of pi on 6 is the same as sine of 30 degrees, which is a half. Yeah, I think I'm right. Log of 2.5, and then that's going to be log of 2. Sine of 0 is 0. So that becomes a half times the natural log of 1.25. Okay, let's see if I'm right. So in the exam, what you're going to do to check if you're right is to use this integration feature on your calculator, which obviously I'm using a graphical one, but you can use this feature on the FX991EXs as well. So I do recommend you check it. I'm going to plug in the original question. You've got to make sure you're in radian mode as well, because I'm using calculus and trig. So the numerator was cos of 2x, so cos of 2x, and the denominator was sine of 2x plus 2. So sine of 2x plus 2, and that is evaluated between 0 and pi on 12. Okay, now if I execute that, that's going to give me a load of junk. But if I subtract my answer, which was a half times the natural log of 1.25, if this was indeed the same as the value of the integral, then this will make the answer 0, which it does. So that confirms to me that my answer is correct. An alternative way to do that is to have the integral value there, and then to type in 0.5 times the natural log of 1.25, and then you can read off that they're both the same number. Of course, you can do that in the graphicals quite easily, because you can see multiple lines, but on the other calculators, you can only see one answer at a time. So I do recommend the previous method for those calculators. Okay, that's that one done. Question number 4, which is question number 5 on the regular paper. On the regular maths paper. So question number 4 on the further maths paper. An artist is creating a design for a large painting. This design includes a set of steps of varying heights in the painting. The lowest step has a height of 20, and the greatest step, and the height of each other step is 5% less than the height of the step immediately below it. In the painting, the total height of the steps is 205, correct to the nearest centimetre. Determine the number of steps in the design. Okay, this looks like a geometric series question. So, spin over the page. Question number 4. So, the first step has a height of 20 centimetres, and then each other step is 5% less. So, well, 5% of 20 is, I should know that. It's 1. So 5% less is 19, and then 5% less of that, 1.19. 19 times 0.95, and so on. So the series becomes 20 times 0.95, 20 times 0.95 squared, and so on, up until you get to the final step, which is 20 times 0.95 to the n minus 1. However many steps there are, n minus 1 because it starts at 0. The powers of 0.95 start at 0, so we finish at n minus 1, so that there are n terms. Okay, and to add the geometric series together, we use the formula, Sn. It's probably at the front of the book, actually. Let's check it out. No, not this book, that book. Yep, there it is. Geometric series. Okay, that's the one we're going to use. The Sn one, not the S infinity, because we're summing a finite number of terms from a geometric series. Okay. So Sn is equal to A into 1 minus R to the N, and we're going to divide that by 1 minus R. A is 20, R is 0.95, N is the unknown at this stage, divided by 1 minus 0.95. So that is the excuse me, that is the sum of the first n terms, which essentially then is the height of all the steps in the painting. And we are told it equals 205 to the nearest centimetre. So in the painting, the total height of the steps is 205 to the nearest centimetre. So we can set the height of the steps is equal to 205 to the nearest centimetre. And then we're going to solve for n. Okay, so solving this for n, times both sides by 0.05. So that's 20 into 1 minus 0.95 to the n equals 205 times 0.05 divided by 20. 1 minus 0.95 to the n equals 205 times 0.05 over 20. Add that and then subtract that, and then log to the base 0.95. So n is going to equal log to the base of 0.95 of 1 minus 205 times 0.05 over 20. Okay, so I'm going to dump that into my calculator. So, calculator, we want general log. There are calculators which don't have this customizable base function, but you can change the base of the log by dividing by some kind of log formula. It's probably at the front of the book again. Okay, so that's 205 times 0.05 over 20, 14.007. So n is 14.007. That is incredibly close to 14. So let's just check, just to make sure that 15 doesn't kind of round to 205 as well. I'll be very surprised if 14 and 15 steps both rounded to 205. So it shouldn't do. So I will leave my answer as 14 steps. But let's just check. I'm going to plug 14 into here and then 15 into here as well. So 20 into 1 minus 0.95 to the power 14, all divided by 0.05. That comes out as 204.93. So that's 205 to the nearest centimetre, which is good. So that's what the question wanted. And if we put 15 in there, I'm expecting it to overshoot. There we go. That's 217 to the nearest centimetre. So we can be satisfied that 14 steps is indeed the correct answer. All right, question number 5. In this question, you must show detailed reasoning. A curve has this equation. It's a cubic. It goes to the origin. That's all I'm spotting so far. Part A, show that the curve has no stationary points. And then part B, show that the curve has exactly 1 point of inflection. It's a cubic. Of course it has 1 point of inflection. All cubics have exactly 1 point of inflection. That's a silly question. Okay, so we've got a cubic curve. Show it's got no stationary points. So we're going to differentiate to start with. So y equals x cubed minus 3x squared plus 4x. Y primed, therefore, is going to be 3x squared minus 6x plus 4. Okay. Show it's got no stationary points. In other words, there are no x values where the gradient is 0. So we're going to solve this equation. X equals minus b plus or minus the square root of b squared minus 4ac. So that's 4 times 3, which is 12 times 48. All divided by 2a, which comes out to be 1 plus or minus root minus 12 over 6. Over 6, which is not real, because you can't square root a negative number in the set of real numbers. So there are no x values then which satisfy this. So no x values, technically no real. No real x values satisfy y primed equals 0. Therefore, no stationary points. Is that what the question wanted? Yes, no stationary points. Because that's what a stationary point is. A stationary point is where y primed is 0 on the curve. All right. And part B, show that the curve has exactly 1 point of inflection. So a point of inflection occurs when the second derivative is 0. So we're going to get 6x minus 6. And we get from the solutions there, x is 1. Only one solution. to y double primed equals 0. Therefore, only one station. No, not stationary point. Only one point of inflection. And that's actually a true statement for all cubic curves, because when you differentiate a cubic curve twice, you get a linear line, and a linear line will always cross the x-axis exactly once. The only time that that's not going to happen is if your linear line is parallel to the x-axis, in which case this would have to be 0, in which case you started with a quadratic, not a cubic. So every cubic ever has exactly one point of inflection. Yes, it's a very silly question. And that was question 6 on the A-level paper. All right, question 6 on the further maths paper, which is question 7 on the A-level paper. The diagrams show 5 different graphs. In each case, the whole graph is shown. So this is the entirety of the graph. There's nothing extra going on a bit later. Okay. Place ticks in the boxes in the table in the printed answer book to indicate for each graph whether it represents a one-to-one function, a many-to-one function, a function that's its own inverse, or that it does not represent a function. There may be more than one tick in some rows or some columns of this table. Okay, all right, so we've got 5 figures here and we've got 5 rows. Okay, so first of all, let's just consider 1.1. Let's see if I can pull this down a little bit. Okay, there we go. Let's see the graph and the table. Right. Figure 1.1 is not a one-to-one function because I can draw a horizontal line and it crosses the curve more than once. So no tick in there. A many-to-one function. It is many-to-one, or it is many to something, because excuse me, there are many x values which go to the same y value. Is it a function? Yes, because there are no vertical lines that cross the curve more than once, so therefore it is a function. So yes, it is a many-to-one function. It is not its own inverse because it isn't reflected in the line y equals x, and it is a function. So that's fine. Okay, figure 1.2. Okay, this is not a function because for any x value we have multiple output values, so I can get rid of those two straight away. It's not a function. Is it its own inverse? No, because there's no line of symmetry in the line y equals x. It's not a function. Okay, so that's the only tick in that row. Okay, third row. Okay, this looks like a quarter circle, but it's a quarter circle. It is one-to-one because it doesn't cross. A vertical line doesn't cross the curve more than once, and a horizontal line also doesn't cross the curve more than once. So therefore, that is a one-to-one function. It's not many-to-one. It's not a function. Ooh, put that in the wrong place. It's not that one. So it's not those two. A function that's its own inverse. Yes, it is its own inverse because it has a line of symmetry in the line y equals x. So therefore, it is its own inverse. 1.4. Okay, again, this is one-to-one because any vertical or horizontal line I draw will never cross the curve more than once. So it is a one-to-one function, which means it's not many-to-one and it's not a function. Is it its own inverse? No, because there's no line of symmetry in that line there. So therefore, it's not its own inverse. That's the only tick in that row. Figure 1.5. It's not one-to-one because I can draw a horizontal line and it crosses the curve more than once. It is a function though, because any vertical line I draw will only cross the curve once. So it's not a tick there or there, it's just a tick there. Is it its own inverse? No, there's no line of symmetry in y equals x. So there, that's the table. Job done. A function f is defined by f of x equals 1 over x for the domain 0 to 2. Let's take the range of f, giving our answer in set notation. Okay. So the range is the set of output values. So I'm going to draw a little sketch here. It's a graph of 1 over x, but it's only valid between 0 and 2, not including 0. Well, I can't divide by 0, and up to 2. So it does include the 2. So it's going to be the kind of reciprocal graph, but then it's just going to stop. And we're going to have an asymptote on the y-axis. So because there's no kind of limit to how close this gets to the y-axis, as it carries on forever, it will get closer and closer. So there's no restriction on the y value upwards. Now it's only valid from x is 2 and smaller, and when x is 2, y is a half. So the set of output values then is y is bigger than a half, or bigger than or equal to a half. So the range, y is greater than or equal to a half. Now it does want it in set notation. So function f is defined by this thing for the domain 0 to 2. Take the range of f, giving answers in set notation. So there's a few different ways you can do this, but you kind of advise you use your squiggly brackets. I would say something like y is defined such that y is greater than or equal to a half. That would score the mark. Or you could say y is defined such that a half is less than or equal to y is less than infinity. Don't say equals infinity though. That would give you the mark. Or we could say y is an element of a half to infinity. That also is okay, and you'll get the mark for that. But it's better to use kind of the squiggly bracket definitions in set notation questions. But yeah, either of those is fine. If you wrote that, you'd actually only get 1 out of 2 marks, because that's not properly defined. Okay. Next question. So question 7 on the further maths paper. This one is not in the regular maths paper. So if you just do A-level maths and you don't do further maths, you would have not met this question in your mock. Feel free to have a look at it now. Pause the video and have a go at it yourself if you want to, if you've covered this yet. Otherwise, you can skip ahead to question 9, I think is the next one. So 7 and 8 are both unique to the further maths students. Okay, question 7. It is given that any integer can be expressed in the form 3m plus r, where m is an integer and r is 0, 1 or 2. Use this fact to answer the following. By considering the different values of r, prove that the square of any integer cannot be expressed in the form 3n plus 2, where n is an integer. Okay, so essentially 2 more than a multiple of 3. That's what that represents algebraically. Okay, 3n plus 2, where n is an integer, is a number that is 2 more than a multiple of 3, or if you like, 1 less than a multiple of 3. Okay, so there's no square numbers which satisfy that, and we're going to prove that now by essentially exhaustion, because we're exhausting all the possibilities for numbers here. So we've got to use this fact. Any integer can be expressed in the form 3m plus r, where m is an integer and r is 0, 1 or 2. So 3m plus 0 is 1. Now if we take that number and square it, we're going to end up with 9m squared, which is equal to 3 times 3m squared plus 0. So that is 3 times an integer plus 0. So this is going to be a multiple of 3, which is obvious because you are taking a multiple of 3 and squaring it. So the answer is obviously going to be a multiple of 3. But this just emphasises that it's not written as 3n plus 2 because it's written as 3n plus 0. Okay, so it's not 2 more than a multiple of 3. It is 0 more than a multiple of 3. Okay, 3m plus 1. So if I take this number and square it, I'm going to get 9m squared plus 6m plus 1. And again, if I factorise out that 3, I end up with a number that's not or cannot be written as 3n plus 2. M is an integer, so it's 3 times an integer plus 1, which means this number must be 1 more than a multiple of 3. So it's not 2 more, it's not 2 more than a multiple of 3. Okay, and finally 3m plus 2 And if I take that number and square it, I'm going to get 9m squared plus 6m twice, which is 12m plus 4. And I'm going to write that as 3 into 3m squared plus 4m plus 1 plus 1. So I've put in, of the 4 here, I've put in 3 of them into the bracket, just to emphasise that this is 3 times an integer plus 1. So this is not written as, there we go. It's not written as 2 more than a multiple of 3, because it is 1 more than a multiple of 3. And those are the 3 options. Either a number is a multiple of 3, it's 1 more than a multiple of 3, or it's 2 more than a multiple of 3. Okay, so that exhausts every possible integer out there, ever. And I've exhausted these 3, because none of them can be written as 2 more than a multiple of 3. Does that satisfy the mark scheme? Can be seen once at the end, or with each separate case. Yeah, that'll be fine. So what I've written there would score full credit. Okay, 7 part B. 3 integers are chosen at random from the integers 1 to 99 inclusive. The 3 integers are not necessarily different. Okay. By considering different values of r, determine the probability that the sum of these 3 integers is divisible by 3. Okay. So 3 integers. If I'm choosing 3 integers, I've got different values of r for each one. Quick tree diagram might help to visualize what's going on here. I'm running out of space. Okay, so the first number I choose is either going to have an r value of 0, 1, or 2. And because I'm choosing numbers from 1 to 99, and it's randomly chosen, so each number has a 1 in 99 chance of being chosen at random. Out of those 99 numbers, 33 numbers have an r value of 0, 33 numbers have an r value of 1, and 33 numbers have an r value of 2. Okay, so there's exactly a third chance of choosing any of those. Okay, for the first number. The second number and the third number are chosen exactly the same way, and in fact, because they can be the same, each choice of number is completely independent of any other choice. So the second number is either going to be r is 0, 1, or 2, 0, 1, or 2, 0, 1, or 2, and then finally the third number is either 0, 1, or 2, 0, 1, or 2, 0, 1, and so on. Okay. There are a total of 27 outcomes, 27 possibilities for the sets of r values. Okay, so of those 27 possibilities, when we sum those numbers together, what is the probability that they are a multiple of 3? Okay, so we need to consider sets of r values. And when I say sets, I mean if I choose 0, 0, 0, that is one set. But I might choose 0, 0, 1, or 0, 0, 2, or 0, 1, 0, or 0, 2, 0, 1, 1, or 0, 1, 2, or 0, 2, 0, and so on. There are 27 of these sets. So this is the first r value, the second r value, the third r value, and there are 27 different ways of expressing these, and how many of those will sum to a multiple of 3. Well, of those 27, you've got 0, 0, 0, which essentially means that the 3 numbers you chose at random are all multiples of 3. So that's obviously going to work. But if you choose 3 values at random, which are all 1 more than a multiple of 3, for example, I don't know, 4, 31, and 97, all of those are 1 more than a multiple of 3. If you add them together, then those extra remainders will all combine to give you an extra 3. So the sum of them is divisible by 3. Or you can do the same thing if r was 2. In which case all 3 numbers are 2 more than a multiple of 3. And when you add those numbers together, for example, 5, 32 and 98. Okay, those 3 numbers are all 2 more than a multiple of 3, but when you add those 3 numbers together, it's a multiple of 3 because your 2 remainders on each case have combined to give you a +6, which is a multiple of 3. So those are the 3 obvious cases, but you can also have a multiple of 3, 1 more than a multiple of 3, and 2 more than a multiple of 3. For example, 3, 4, 5. Okay, if I add those together, I get 12. That's a multiple of 3. But the 3, 4, 5 could have been chosen in any order. So we've got to look at the permutations of 0, 1, and 2. And there are 6 permutations. So that's 0, 1, 2, 0, 2, 1. So that's the first number was a 0. If the first number was a 1, then you'd have to have 0, 2, or 2, 0. And if the first number was a 2, then you'd have to have 0, 1, or 1, 0. Okay, so those are the 6 permutations. So there are 3 up in this category, 6 out in this category. So that's a total of 9. There were 27 altogether. So the probability is 9/27ths, or if you like, 1/3. And there we go. That's the answer, 1/3.